Today, inshallah, we will continue 7.1. If you remember, we have started this section in the previous class. The idea of integration by parts, it is just about integrating. Usually, when we have a product of functions, we use this technique. But of course, we can use it also with logarithmic functions, with inverse functions, and other types. So here what we need, ya shabab, we need to determine u and dv. If you have an integral, let one part be u and another part be dv. Then what you will do, you will, so you have now, what you have u, you have dv. Here you will integrate, you will differentiate, you will find the derivative. Here you will integrate. Then you will multiply the integral here, this integral that you have, this is your integral. It will be uv minus v du, just like that. We have find this integral, if you remember in the previous class, x sine x. And of course, also we know now what is the integral of ln of x. Here it is. You can add it to your table of integration. Usually when you have ln included, it is better to, of course, it works well if you put it equals to u, because you know the derivative, it is 1 over x. You don't have ln anymore. And of course, when you have power function, in this case, you may need to integrate another time or several times. What is important, that if you choose u to be, unusually, ya shabab, when you have a power function here, choose it to be u until such that you will differentiate it. And when we differentiate power functions, we get simpler functions. So, but in that case, if the power is 2 and more, you may need to integrate by parts a second time. So if you need to integrate another time, you should keep your choice unchanged. You choose u to be the power function and dv to be the exponential. Do this. Don't change your mind. If you did, you will cancel what you did in the previous integration. And of course, it will be much easier if you use the tabular method. Just here, put a table. Here, put u and its derivative until you get 0, because it is a power function. And here, put dv and the integrals of dv. Then multiply alternatively sign. When you have positive, negative, positive, just multiply this by this, minus this by this, plus this by this. You will have the same answer. We applied also this method to this integral, in which we need to integrate 3 times. So usually this tabular method, it works well when we have integrals of this type: power function multiplied by sine or cosine or exponential. In this example, we bought u, when you have exponential and the logarithmic function. Sorry, trigonometric. When you have exponential function and trigonometric function, it is here. It makes no difference, ya shabab. It doesn't matter here if you put u equals to e to the power x or sine x. It's okay. Here in this example, we used u to be the exponential function and dv to be sine x. I advise you to put u equals to sine x and dv to be e to the power x. Why? Because you know, ya shabab, you know from 101 or math 101 what is the derivatives easily. So this is the derivative of cosine is sine. Because I have noticed that some students, they forget the negative and positive signs when they integrate. But when they differentiate, they still remember it. Okay? So I think it will be more clear if you put u equals to sine, but the answer is the same. Please try to apply this way or this way. The answer at the end is the same. You will get the same answer. So it is not that important. What is important in this example, if you remember, is you are going to have an integral from the same level of the original integral. You need to apply it again. Again, don't change your mind. Keep, if you choose u to be the exponential, keep on or stuck with your choice. Don't change your mind. Then look here, what is the case that we may have? This is very common when you integrate by parts several times. We get our integral back. It is the same integral that we have. So we will add it for both sides, and here it will be disappear. Here it will be the double of the original integral. To find the integral that we want, divide by 2. And that's it. This was, I think, the last example that we solved in the previous class. What we will do today, we will solve, or we will integrate or find the integral of this function. And look here what we have. We have the integral of tan inverse of x. And you can do the same if you want to find the integral of sine inverse and other trigonometric functions. What is new here also that we have limits for the integral. This is the first example with the definite integral. So it is not a big deal. You can apply the integration by parts formula if you want. When you integrate by parts and your integral is definite integral, no problem. Do what you do usually. Then at the end, just substitute the upper minus the lower. So any idea here, Shabab? Now this is my integral. I'll try to think about this like u dv. So what do you think, Shabab? What is u? What is dv here? What
u is sine inverse.
We need to choose u to be what?
Sine inverse.
Sine inverse. What is sine inverse?
Tan.
Tan inverse, you mean? Tan inverse of x. So what is remaining? Class. This is u. So what is remaining is dv. Thank you. Abdullah al-Hussein, Abdullah. Let me ask Abdullah, are you with us, Abdullah? Abdullah al-Hussein? Abdullah al-Hussein. Abdullah is not here. Let me ask Akbar al-Nasir. Yeah, Akbar.
Yes.
What is the du?
The du is dx.
U, Akbar, u is tan inverse x. What is du?
The derivative.
What is the derivative, yeah, Akbar? What is the derivative of tan inverse?
1 over 1 plus x squared.
And we should write here what? dx. Don't forget the
dx.
differential. Good. This is dv. So what is v, Akbar, here? If dv is dx, what is v?
X.
It is x, yes. The integral, we integrate here. We have 1 dx. When we integrate, we have x. So here we differentiate, here we integrate. Thank you, Akbar. Now what we will do, ya Shabab, we will just apply the formula uv minus v du. This formula, uv minus v du. So this will be equals to the integral of tan inverse x dx will be equals to uv, which will be x tan inverse x. This is u, you can write this is u, this is v. But ya Shabab, this is not practical. You may think that x is inside the argument of tan inverse. So it is not practical. You know that the product is commutative, so put it here in front of the tan inverse. Minus this minus from the formula, minus the integral of v, this is v, multiplied by du, this is du. 1 plus x squared dx. Okay? So now let me write this in this way. I think we have it here. This one. Okay? Now let me ask, ya Shabab, someone who can tell me, ya Shabab, what is this integral equals to? Immediately, what is the result? Forget about this, the limits. I'm asking about this integral. It is equals to what? I think now I know that some of you, they are able to get the right answer quickly. What is this equals to, ya Shabab?
X tan inverse of x.
X tan inverse of x. This one?
Yeah.
No. No. Muhammad
ln
Al-Hindi,
ln absolute value of x.
ln absolute value
Of x.
of x. No. Muhammad Al-Hindi, why your name is like
Yes.
that today?
Dr. 1/4 minus 1/4.
No. No, no, I'm not asking about ya shabab, forget about the limits. Think about
Oh,
this. The
one
indefinite integral.
ln 1 plus x square over
over
all
2.
over 2.
Who said that? Who said that?
Ibrahim.
Ibrahim Bagazi. Allah yarda alayka ya Ibrahim. It is 1/2 ln the absolute value of x squared plus 1 or 1 plus x squared. But you know that x squared, the absolute value of 1 plus x squared. This is 1 plus x squared. It is positive. No need for the absolute value, by the way. Allah yarda alayka ya Ibrahim. You need another bonus. You had bonus from yesterday. Excellent, ya Ibrahim. And also for Fadil. Fadil also, he mentioned this answer. Good, ya shabab. طبعا يا شباب, all of you will be able to do that, I'm sure, but not now. After you practice 5.5 again and again, 5.5, 5.5, 5.5 يا شباب. Revise that section, the substitution rule. Muhammad Al-Hindi, you wrote your name today in a strange
Yes.
way. You have A, B, D, U in front of your name. Please, ya shabab.
Okay, I fix it. No problem.
You don't
I have
need to
to
write
go
your
out
name every
and then-
time. It should be automatically registered if you use your KFUBM account. I wish that these problems will be solved at the end of this semester. After 6 weeks, we still have these problems. Now don't worry, ya shabab, if you cannot get the final answer automatically like what Ibrahim or Fadil did, it's okay. You can use substitution. So now, ya shabab, what he did, of course, he just multiply UV minus VDU. This is UV, this is VDU. طبعا he has a definite integral, so he will evaluate now. No problem, you can delay this to the end. For me, I prefer to do this, and it is up to you, shabab. For me, I will integrate without the limits until the end. Then at the end, I will put from 0 to 1, and I will continue. Okay, so this is my way. But of course, you can do that to save some time. It will be better to do the calculations here while you are still working. So here it will be the upper minus the lower. So it will be 1 tan inverse 1 minus 0, 0, whatever. It is multiplied by 0, it will be 0. Minus the integral of 1 over 0, this one. Now here, tan inverse 1 is what? What is tan inverse 1?
Pi over 4.
Pi over 4. So we have pi over 4 minus this integral. Now let's come to this integral. This integral, if you notice, if you put this equals to u. So if we let u, but I don't advise you to use u when you have u here. We have u here, ya shabab. We use the letter u to be tan inverse. So I advise you, it's okay, you can use it, no problem. But sometimes you may get confused. So I prefer to use, we have many letters, so let's call it T. For example, Z, W, V, whatever. So let's call it, no, V, we have V. So you can use other letters other than V and U. Let's say T. If T is 1 plus x squared, then this is a substitution, ya shabab. This is 5.5. Then dt will be 2x dx. Notice that we have x dx here. So if I put this as t, here I will have dt, maybe multiplied by a number, divided by a number, it's okay. So here, if you look at x dx, what is x dx? X dx, it is just divided by 2, it is the half of dt. So this is dt over 2. So now my integral will be the integral of 1 over t, dt over a half. So the half will go out, and we will have dt 1 over t dt. طبعا not from 0 to 1. If you wrote from 0 to 1, it is wrong. You should change also the limits of the integral. So you have x from 0 to 1. When x is 0, what will be t? T will be 1. When x is 1, it will be 1 plus 1, it will be 2. So your new integral will be from 1 to 2, not from 0 to Here we are. So this is the half of dt over t. Now this will be, of course, negative a half ln the absolute value of t. And of course, you will substitute now the upper minus the lower. It will be ln 2 minus ln 1. Ln 1 is 0. So it will be pi over 4 minus ln 2 over 2. So let's now think about how Ibrahim or Fadel got it immediately. They look here and they found that we have here f of x. And here in the denominator, we have f prime of x. So what they did, they just say the derivative, it is 2x. I will multiply by 2 and divide by 2. Now what I have here, I have an integral like this. So this will be the half of ln f of x. And this is what I told you yesterday to generalize. I wanted to write this in general for any function. Just you need to notice if the problem is just you have a constant that is missing, you can multiply by that number. It is not difficult. طبعا يا شباب, here I told you, you can do this also for sine inverse, the integral of sine inverse, the same way. Please try to do it. You can also generalize it for any inverse. If you have an inverse for a function, you can do the same as we did here. You will put u equals to the inverse, dv will be equal to dx, du will be the derivative of the inverse, whatever it is, v will be x, and then you will apply the integration by parts formula. Give me any inverse, I can apply this. Now, another way or another applications for the integration by parts is the reduction formulas. What are the reduction formulas, ya shabab? It is a formula that can give you, let's say, a technique or a method of reducing the powers from n, here we have sine to the power n, to integral of sine to the power n minus 1, minus 2. So if you have the integral of sine 4 to the power 4, you will have it something, and then you have integral of sine squared. Then you can apply again and continue. So this method, in fact, you don't need to recall this formula. Just you need to apply it when n is 2, 3, 4, 5, 6, and so on. So we will not give you that in very big integer. It is just few integers at the beginning. So what is the technique? You will use the integration by parts to prove this, to show that it is correct. So what is the trick that you need to do at the beginning is this. What is this? Let me stop sharing this and share it again. So now what we have here, okay, I think it's okay now. What we need to do is to find what is u, to think about what is u, what is dv. So in this case, we will choose, here we are. Can you see, Shabab, the slides now?
Yes.
So what we will do now, just we will do this nice trick that we need to now decide what is u, what is dv. So, but of course, if you use u to be sine to the power n and dv to the power x, it will not be that practical. So what is the trick? The trick that you will write sine to the power n x dx as the integral of sine n to the power negative 1x sine x. Is it okay? What I did, I just used the idea that sine to the power n, it is just sine to the power n minus 1 multiplied by sine. If you multiply this sine by this sine, 1 plus n minus 1 will be n. Like when you have sine to the power 4, it will be sine to the power 3 multiplied by sine to the power 1. The same way. Now what we will do, you will put this equals to u, this will be u, and all of this will be dv. So we will let u equals to sine inverse. Sorry, not sine inverse, sine n minus 1, and dv will be sine x. Now the du you will differentiate. Here you will differentiate, here you will integrate. When you differentiate this, you need to apply the chair rule, if you remember, Shabab. It will be n minus 1 multiplied by sine n minus 1x cosine x dx. Don't forget to multiply by the derivative of the inner function. And the integral of sine x is negative cosine x. Multiply now uv minus dv minus the integral of v du. This is what we have. Is it the same as the formula that we need to prove? Not yet. I think we have this part. Here it is. And the negative, we still here, we need it to be in terms of integral of sine only. If you look here, we still have cosine squared. So how to get rid of this cosine squared? We will use the identity, the Pythagorean identity. Cosine squared is just 1 minus sine squared. So just use this identity here. So what you will have this as it is, this as it is, just this cosine squared, write it as 1 minus sine squared. Then distribute. If this is 1 minus sine squared x, so this multiplied by 1, you will have this integral. Then this multiplied by this, n to the power negative 1 multiplied by 2, it will be added to 2 طبعا. It will be sine to the power n. If you notice, this integral here is the same as the integral that we started with. But here it is n minus 1, so you can move it to here or add it for both sides. So here what we will have, you will have 1, we have 1 of this integral. It will be added to what? To n minus 1. This negative 1 will be cancelled with the negative 1, and you will have this integral multiplied by n. So we have n of this integral. This is as it is. This is as it is. All what we did, just we move this to the another side and simplify. Now, if you want this integral, you will just divide by what? By n. Okay? And it is exactly the formula that we are looking for. If you want to find the integral of sine to the power 3 dx, you can apply this. Just do the same, shabab. Do as the same as we did. So you will write it as sine squared x, sine x dx. Then, of course, you can use, you can solve it by other way, by the way. Here it is easier to use 1 minus cosine squared and use the substitution. But of course, when you have it, for example, to the power 4, it will not be that easy. You need to work more. So like this. You need here to apply integration by parts. You can do that also for cosine to the power n. You have a similar formula. And apply it here, shabab, as an exercise for cosine squared and cosine to the power 4. These are some suggested recitation and practice problem. We will solve the recitation problems, inshallah, next class. Let's summarize. So now when you integrate by parts, try to let dv to be the most complicated part of the integral that fits a basic integration rule. So when you choose dv, it should be easy to be integrate. And of course, the remaining part will be u. Or let u be the part of the integral or the portion of the integral whose derivative is a function that is simpler than u. Also, when you choose u, try to get du simpler than u. And of course, always remember that dv is always includes the x. Don't forget it. We have several types of integrals that we can use integration by parts with them. When you have a shabab integral like this, power function with multiplied by exponential, power function with trigonometric sine or cosine, then always both u equals to x to the power n and dv to be the other part, the remaining part. And here in this case, you can use Taylor method. In this case, if your integral is like this, x to the power n ln x, x to the power n sine inverse, x to the power n tan inverse. In this case, both u equals to ln x, both this part, both it equals to u, and dv, both it x to the power n dx. This is very important trick here. Look here, it is the opposite from the above one. For the third one, when you have exponential multiplied by sine or exponential multiplied by cosine, it is so easy. Both u here equals to sine or exponential, it is the same. It will not be that much different, but of course it will be a little bit easier when you use sine, the trigonometric to be sine, the u to be sine or cosine. Is it clear, Shabab? Let's apply this for this all the exam question because we need to get ready for the quiz, Shabab, in 5 minutes. So let me share with you a poll about this. And I want you to solve it, Shabab. Please take a pen and paper and start solve. And this is good practice for you for the quiz. Find, of course, here the volume of the solid obtained by rotating this region. The region is bounded by y equals 3 sine x, y equals 0, which is the x-axis. From x equals 0 to x equals pi. Very easy question. The rotation axis is the y-axis. You are going to rotate it about the y-axis. Yalla ya shabab. Please take a pen and paper and start solve. طبعا you need to sketch the region. Determine what is the method that you are going to use. Are you going to use the cross sections method, washer or discs, or you will use the cylindrical shells? Only one method will be easy here to be used. Who choose C? Are you kidding? Are you playing? This is not a game at all. Another one choose B. You are doing a silly game. This is not mathematics. You cannot do that. Impossible. Unfortunately, ya shabab, there are some students, they are not serious at all about practicing. يؤسفني أن أقول ذلك، لكن في كثير بيستهبلوا يا شباب. ما أدري ما أخذين الموضوع، ما أدري إيش أقول. نسأل الله حسن الخاتمة بس. You have to be يا شباب more disciplined, please. Okay. Continue, Shabab. Let me help the students that they didn't start by sketching the region. So where is the region here? So what do we have? We have, let's say, this is the axis of rotation. This is y-axis. And this is x-axis. This is the origin. You know how to sketch 3 sine x. It is, the amplitude is 3. So it will be like this. And from where to where? From 0 to pi. Halas, up to pi. It will be something like this. This is pi. And of course, you know that the graph of sine is doing like this. This is 0. This is pi. What is the other curves? This is y equals to 3 sine x. What is the other curve? Y equals 0. This is y equals 0. From x equals 0 to x equals pi. Very easy. And this is the axis of rotation. So where is the region that we are going to rotate? This is the region. This is our region. Now what we will do, let me see now how much, mashallah, you're still working. Continue working, ya shabab. Now, if you want to use the 6.2, if you want to use 6.2 ideas, يعني cross sections, you will draw a line perpendicular. You will draw a line perpendicular to the axis of rotation like this here. But you don't know what is the x on the right, what is x on the left. You don't know the inner radius and the outer radius in this case, because you will ask yourself, what is x here? What is x there? You cannot find what they are. So you cannot here indeed. It is not easy at all, because you need to find sine inverse in the first quadrant, and in the fourth quadrant. It will not be practical at all to use cross sections. So instead of drawing a line perpendicular to the axis of rotation, draw a line that is parallel to the axis of rotation from the upper part to the lower part. Now it means that here we will use washers. So the method that we will use is sorry, not washers, shells, cylindrical shells. So we will use 6.3. Let me see the results. How many students so far? Let me end the polling and show you, ya shabab, how you are disagreed about the answer. You, mashallah, you distributed your choice over all the choices. But most of you, they choose, of course, choice A, which is the right one. The right answer is A. Now, what we will do, ya shabab, you know that the length of this line will be h, and the distance from the line that you draw to the axis of rotation will be r. And this line, because it is vertical, it will be x. We will call it x. Now the question is, of course, the volume will be the integral 2 by RH d dx, because this is vertical, perpendicular, and x-axis. Now from where to where? X is from where to where? X is from 0 to pi. It is given, and it is clear from the region. Now the question is, what is r? What is r here? So r is the distance from the line that we draw to the axis of rotation. So it is x minus x equals 0. So it is x minus 0, it is x. For h is the length of this line. It is the upper curve minus the lower curve. So it is 3 sine x minus 0. So it is 3 sine x. Now come to your integral. So the volume will be the integral of 2 pi, the integral from 0 to pi. For r is x. What is h? H is 3 sine x dx. Here we are, this 3 will go out, and it will be 6 pi, the integral from 0 to pi, x sine x. You remember, ya shabab, we have integrated x sine x in the previous, in the first example, if you remember. Just you need to put, what you will do, you will put u, this is equals to u, this is equals to dv. And then, of course, you will find du and dv. You can continue doing that. Okay? So let me do it, of course, for you. So we will choose here u equals to x, dv will be sine x, dx, and du will be what? dx, 1 dx. V will be negative cosine x. And this integral will be equals to 6 pi multiplied by uv negative x cosine x minus negative minus v du. So it will be minus, it will be plus the integral of cosine x dx. From where to where? From 0 to pi. This is equals to 6 pi, the integral of u. What is the integral of cosine x? The integral of cosine x is sine x. So here we are, shabab, just substitute, you will get pi. 6 pi will be multiplied by this, it will be 6 pi squared. We don't have much time, and we will go now, ya shabab, to the quiz. I want you to be ready, and let me stop recording at the beginning. We have now quiz number